Johnson's test correction video for exam 1. Question number 1 gave us vector P and vector Q, and we're supposed to find what vector PQ is. And what I did on my exam, I drew the vectors together. I did the P and Q, and you draw them from tail to tip, and since they gave us P to Q, I did tail to tip on P and then tail to tip on Q at the end of vector P. And what I did wrong was I drew vector Q a lot longer than it was actually shown, which resulted in my final vector pointing this way, which is why I got answer A. When in reality, the vector is shorter, so it should have been coming out to the right, which would be our answer for D, which is how you get that. And then for question 2, it asks us which of the following situations is impossible, and the correct answer was D. And how you get D, it says an object has constant non-zero velocity and changing acceleration. And when you look at the equation for acceleration, it's the change in velocity over the change in time. And you can't have a constant non-zero velocity and then having a changing acceleration. You need to have a changing velocity to get a change in acceleration as well. So that is impossible. Now for question number 5. Question number 5 down here. It says an airplane traveling with a constant speed in a circle drops a bomb. Where does the bomb hit the ground relative to the airplane? No air resistance, and the airplane continues moving with a constant speed in the circle. What I failed to notice when I was reading the problem was that it is going in a circle. I thought it was just going in a straight line, which is why I said B, because if it was going in a straight line, eventually the two would meet and the bomb would be directly under the plane. But since we are going in a circle, I drew a little picture. The plane is going in this circle right here. The bomb has no force to continue to push it into the circle, so it will just use the continual motion forward, and it will continue on that tangent line and land outside of the circle the plane is moving in. And that was option D. And then for question number 8, let me get there. This one, I don't even know what I was doing. It says a remote controller has been programmed to have velocity v is equal to that, where t is in seconds. What are the components of the acceleration of the car at t is equal to 3.5? And when it says what are the components, it's asking what the x and the y's are of the vectors. And as you can see, I only got one answer. Down here, looks like I did take an integral of it, and I got an answer, but I did not have the two components split up. So that is obviously wrong. What you need to do, looks like on here, so you take the integrals, but you have to take the integrals of knowing that this is x and this is y, basically. So you take the integral of it, and I got this right here, and then you evaluate it when because it says the components of the acceleration of the car at time is equal to 3.5 seconds. So you evaluate it from 0 seconds to 3.5 seconds. And I got this for that. And so this is what you plug in for 3.5 seconds, and then you subtract whatever you plug in for the 0 seconds. And then you add the x and the y's together, and I got this. And these are both the x and y components for that vector. And then for question 12, I didn't really get to finish it, but I'm out of time. It says Romeo is throwing pebbles at Juliet's window 7 meters up and 10 meters from the base of the wall. The launch angle is 37 degrees from the horizontal. What is the initial speed of the pebbles? And on my test, I drew this lovely picture of Romeo and Juliet. And as you can see, we are 10 meters from the base and we are 7 meters high. And then our launch angle is 37 degrees. And so this angle is the 10-7 right here. And let's see, so to do this, we know that our initial velocity, or I believe that is the magnitude, I could be wrong on that, but anyways, so I plugged in, or I solved the equation for different parts, as you can see, and this is our equation that we have from our notes in class, and I was able to plug in what I knew, and then I was able to plug in this, so Vy is equal to Vx tangent of 37 degrees, and I was able to plug that into that equation that we knew, and I got this. And then we can also substitute in what we knew for Vx, which I solved for up here, it looks like, and that was 10 over t, and the 10 is the 10 meters from the base of the building, which is the x. And so changing the x over time, and so I substituted that in, and that's what I got from there. And obviously I don't have time to finish it, but those are my test corrections.